Hi students, do you feel any difficulties while doing these organic conversion questions? Here we have the solution. Top 30 questions we are going to discuss from the chapter Haloalkanes and Haloarenes. Those who are going for your board examination 2025 chemistry, out of 70, around 33 mark is from organic itself. So, you can able to understand what is the importance of organic chemistry chapter. And the students are feeling difficulties while doing the organic conversion question. How they ask you the questions, how will you convert this compound to this compound? Maybe one single step you can able to complete. Sometimes it need 2 steps, 3 steps, 4 steps like that. So how can we understand which method we need to apply? So first of all, we have to know the organic, the reactions, every reactions which is included in our organic chapter. So here we are discussing about haloalkanes and haloarenes. Okay, one of the easiest chapter where 30 important conversion questions we are going to discuss. So this is not just a discussion of conversion question. Along with that, you can remember, you can revise it, which all reactions are there in the chapter. It's a recap of all the organic chapter. Haloalkanes, we are starting as a first session. Let us go for the first question. How will you convert, what is the question everyone? Propene to propanol. So let me write the compound first of all. What is propene? Right, this is what we call propene to what? Propanol, right? Propene to propanol. So whenever you get a question, first you write what is the reactant, and what is the product, and check it what's the conversions required for that one. Check it all. Here this is an alkene and this is an alcohol. Ready? So if you want to bring, you have to get a OH group on the first carbon, right? So directly we can't able to bring any OH on that one. But to alkene, we studied how to convert into haloalkene. So let us start the first step. CH3, CH double bond, CH2. What is this? Propene. To propene, when you add, for example, HCl or HBr, H plus is there, Cl minus is there. But if you add HCl, see chlorine goes to this carbon, H plus goes to this carbon. But we need to get a chlorine on this first carbon because we need to convert that into OH. So we can't able to use HCl in the beginning. We have to use which one? HBr. HBr in presence of which one? Peroxide, right? Peroxide. So if you want to apply anti-Markovnikov's rule, what we have to use it all? HBr in peroxide we have to use it. What happens if it is anti-Markovnikov's rule? Negative part goes to carbon with a more number of hydrogen, and positive part goes to carbon with a less number of hydrogen, and you will get the compound CH3, CH2, CH2Br. What it is called? 1-bromopropane. Now bromine is ready on the end, first carbon. Now the bromine we need to convert into OH. That's it. So do you remember which reagent is used to convert a halogen into alcohol? We have aqueous KOH. Very carefully use the reagents, okay? Aqueous KOH, nucleophilic substitution. The Br goes OH substituted. You will get the compound CH3, CH2, CH2, OH, propanol. So how will you convert? So again do the questions, okay? Propene, how you can convert it into propanol? First propene, do anti-Markovnikov's rule with HBr. Then you will get bromine on the first carbon. Then bromine, if we want to replace by OH, we have to use the aqueous KOH. So what all reactions are there here? First step is anti-Markovnikov's rule. Second step is the nucleophilic substitution reaction. Ready? Question number 2. 1-bromopropane to 2-bromopropane, and they ask you the reverse also. So 1-bromopropane. So let me take 1-bromopropane first. Ready all? 1-bromopropane. You have to make into 2-bromopropane, right? 2-bromopropane. So it's very easy. While looking the compound, it's very easy. We want to just bring the bromine from the first position to second position. Sir, it's very easy. Remove this Br and put it on this carbon. Yeah, it is possible by writing, but they are asking through a chemical reaction, we have to show the conversion. Ready? So how to convert? So let me take the compound CH3, CH2, CH2Br. This is our 1-bromopropane. If you want to change the position of any halogen, First, completely remove the halogen. Later, we can bring it back. So, how can you remove this Br? We can remove Br by alcoholic KOH. That's nothing but our beta elimination reaction. What is beta elimination reaction, my dear? Halogen go from alpha carbon, one hydrogen go from beta carbon and make a double bond between alpha beta. We will get the compound propene first. Now, to propene, if you want to get one bromine on the second position, what we have to use? HBr alone. Marconico's rule, it will be applied. So H plus is there, Br minus is there. You know, negative part goes to carbon with a less hydrogen. Positive part goes to carbon with a more hydrogen. We will get 2-bromopropane. So dear, if you want to change the position of any halogen, you have to first completely remove the halogen. That's by beta elimination. So how to convert 1-bromopropane to 2-bromopropane? First to do beta elimination, then Marconico's rule. I will give you the other question, opposite one. Here 2-bromopropane to 1-bromopropane. Same method, a small difference. Here we have 2-bromopropane to 1-bromopropane. So first of all, completely remove the halogen. Completely remove the halogen. So halogen go from alpha, hydrogen go from beta. Both are same. So then put a double bond here by using alcoholic KOH. So we get propene. Ready. Propene is ready. Ready. To propene, we have to bring our HBr back. HBr we have to add now without peroxide or with the peroxide? With the peroxide. With the peroxide, then only anti-Marconico's rule can be applied. Negative part goes to carbon with the more and H plus go to the less. You will get 1-bromopropane. Clear everyone? So they ask you to convert 2-bromopropane to 1-bromopropane, first of all, completely remove the bromine from the position by alcoholic KOH. That's our beta elimination. Then you have to add HBr in peroxide. So anti-Marconico's follows and we'll get the product. Clear everyone? So but here how it's that? Here first beta elimination and normal Marconico's rule. Let's go for the fourth question. Toluene 2. What is toluene? Toluene is benzene with CH3 is called toluene. Toluene to benzyl alcohol. What is benzyl alcohol? See all? Benzene with a carbon. This is called benzyl alcohol. How can we do this? It's a two-step process, my dear. So let us start from toluene itself. Okay? Toluene is ready. Toluene on which how can you bring a OH group? That's a question. Directly we don't have any method. We can add chlorine in presence of light, HNu. What is this reaction called? Substitution. You know, substitution happen only on alkane chain, right? The alkyl part. So what is substitution? Remove one hydrogen, add one Cl. So you will get benzene with what? CH2Cl. What it is called? Benzyl chloride. Benzyl chloride. So remember, toluene on substitution reaction, we get benzyl chloride. Now how to convert chlorine into OH? That's we have aqueous KOH. If you use aqueous KOH, you will get CH2OH and this KCl out. Okay all. So if you want to convert toluene to benzyl alcohol, first toluene undergoes substitution. We get benzyl chloride and aqueous KOH will give you what? Benzyl alcohol. Next question. Benzene to which one? 4-bromo-nitrobenzene. 4-bromo-nitrobenzene. See all of you that this question is actually based on your 11th grade one concept. 11th grade hydrocarbon chapter. You know, here we have to bring the nitro group. That for that we have to do nitration. If you want to get bromine, you have to do bromination. But which will you do first? That's a question. See, you know, nitro group is a meta-directing group. Halogens are weak ortho-para-directing group. I'll give a hint all of you. If your product is para, here product is para, right? This is the hint. If the product is para product, then the ortho-para-directing group add first. Once again, if your product is a para product or ortho product, the ortho-para directing group identify that you make it first. If you want an opposite, if you want a meta product, then the meta directing group add first. For example, here the product is para, right? Para way. So if the product is in para cases or ortho cases, the ortho para directing group add first, which is the ortho para bromine. So let me do bromination first. How to do bromination? Br2 with the catalyst FeBr3 dark. Then you will get bromobenzene. Now the bromine will decide where the next group to come, because bromine is an ortho para directing group. So then if you do nitration, how to do nitration? Concentrated HNO3 and concentrated H2SO4 heat. Then what happened? Nitro group comes, only one choice, it can go to the para position. And don't think, dear, these different product, right? While numbering, these compounds are same one. So this is the condition, my dear. If you want a para product, the ortho para directing group add first. He will do the rest. If you want a meta product, then meta directing group add first. Ready? Next one. Ethanol to propane nitrile. What is ethanol? CH3, CH2, OH is called ethanol to propane nitrile. You know, nitrile means cyanide. What is propane nitride formula? CH3, CH2, CN. Here how many carbon? 2 carbon in reactant, 3 carbon in product. If you want to increase 1 carbon extra, definitely we have to bring cyanide. Okay, so that you keep in mind. So what I am doing is, the ethanol, first I am converting into a haloalkene. For example, let us treat it with a thionyl chloride. What is thionyl chloride? SOCl2 or a PCl3, PCl5, anything. The OH is converted towards Cl. So you get CH3, CH2, Cl. Now you know haloalkane is ready. From haloalkane, how can we prepare cyanide? By treated with alcoholic KCN, potassium cyanide. Use KCN, okay, because AgCN give you isocyanide. So alcohol first we converted to haloalkane, because haloalkane only react with which one? KCN, and give you the cyanide CH3, CH2, CN. So if you want to increase 1 carbon extra, definitely we have to bring which one? Cyanide in most of the cases, especially the haloalkane chapter. Ready all? Next one. Aniline to chlorobenzene, one of the easiest reaction, you know, aniline. Aniline directly we can't able to convert into which one? Chlorobenzene. First we have to do diazotization. What is diazotization, my dear? NaNO2 and HCl at 0 to 5 degrees Celsius when you treat, the NH2 become N2Cl. What do you call this salt? Benzene diazonium chloride. This benzene diazonium chloride, how you can convert it to chlorobenzene, bromobenzene, iodobenzene, fluorobenzene, everything you studied. How to make it chlorobenzenol? Cu2Cl2 along with the HCl, or Cu powder with HCl. This is Sandmeyer. Copper powder is which one? Getterman. Any reaction we can choose it. You get chlorobenzene and nitrogen gas. So aniline on diazotization we get benzene diazonium chloride, that's on Sandmeyer, or we can use Getterman, then chlorobenzene is ready. Question number 8, 2-chlorobutane 2. What is that compound, all of you? 2-chlorobutane, okay? This is our 2-chlorobutane compound. 2, 3,4-dimethyl hexane. Hexane mean how many carbon? 6 carbon. 3,4-dimethyl hexane. Okay, 3,4-dimethyl hexane. How it is possible? Come on dear, how it is possible? Check it all of you. How many carbon in this compound? 1, 2, 3, 4. 4 carbon in reactant. How many carbon in product overall? 8 carbon. 4 becomes 8. That means Wurtz reaction. If there is a doubling in number of carbon, that will be Wurtz reaction. So how to write Wurtz reaction? So let me just change this compound format. You know what is Wurtz reaction? It's a combination of 2 same haloalkane. So this is the haloalkane given here. So let me take the haloalkane. Can I write this 2-chlorobutane like this? Tell me all. Can I write this same, this 2-chlorobutane as this? Yes, right? 1, 2, 3, 4, 2-chlorobutane. But you know, Wurtz reaction mean 2 same compound we have to join. So let me take one more same compound here. CH3, CH2, CHCl and CH3. Are they same compound? Ready. And in between what we are using? 2 sodium. Balancing not compulsory there. 2 sodium. Why we are using sodium? And you know the medium is what? Dry ether medium. Yes, my dear. What is Wurtz reaction? When haloalkane react with the sodium in dry ether, we get higher alkane. How it is? Sodium take this chlorine out. So 2Na take both of the chlorine and 2NaCl out, and this alkyl group joined with this alkyl group, you will get the compound CH3CH2, CHCH3, CHCH3 and then again CH2CH3. Yes, we are getting the product. So if there is a doubling in number of carbon, we can ensure that it can be mostly Wurtz reaction. Carefully try to hope you get that point, all of you. Dimethyl hexane. Question number 9. 2-methyl propene. What is 2-methyl propene? This is what we call 2-methyl propene. 2-chloro 2-methyl propane. 2-chloro 2-methyl propane. How it is possible? Simple reaction, right? Simple reaction. Can you say which reaction? That's just to add HCl. Marconi-Kos rule. According to Marconi-Kos rule, negative part goes to carbon with less hydrogen, positive part goes to carbon with more hydrogen. You will get that product just one single step. Question number 10, ethyl chloride. Yes, what is ethyl chloride? CH3, CH2Cl. Ethyl chloride to propanoic acid. Propanoic acid. Yes. Here one reaction we need extra, that is I am taking from the aldehyde ketones and carboxylic acid. Okay, because you know dear, you are going to write the board exam after studying all the 4 organic important chapters, right? So where interrelated chapter questions will be there. Maybe one step from haloalkane, second step maybe alcohol chapter. So interrelated questions will be there. Chapter related one. So I am taking this compound once again. CH3, CH2Cl. What is this? Chloroethane. See, your reactant contain 2 carbon, product contain 3 carbon. So of course there is an increase in carbon. If you want to increase 1 carbon extra, definitely we have to bring cyanide. So let's bring cyanide. How to bring cyanide, all of you? Alcoholic KCN. Okay. So we will get CH3, CH2, CN, right? This K and Cl cut will get cyanide. Now 3 carbon is ready, but we need an acid, not cyanide. How to convert cyanide to acid? Please study all. That is by acid hydrolysis. What is that? Cyanide on acid, complete acid hydrolysis will give you cyanide that converted to carboxylic acid. Okay. Okay, all. So if you want to increase 1 carbon extra, please bring cyanide. For that, a haloalkane is required. So haloalkane react with the KCN, you get cyanide. Cyanide on acid hydrolysis, complete acid hydrolysis, you will get carboxylic acid. Question number 11, but1-ene. What is but1-ene? Ready? But1-ene. 2N-butyl. What is N? Normal. Normal. Straight. Normal butyl iodide. How it is possible? How it is possible? 2 steps, right? Okay, my dear, tell me. This is but1-ene. How to get a iodine on this place? We can't use HI with the peroxide, okay? But the peroxide anti-Marconi-Kos rule possible with HBr. Don't use HI and all. So we have one method. Let me bring HBr. Let me add HBr in presence of peroxide. Means we are applying anti-Marconi-Kos rule. So you may ask the question, sir, we need iodine, right? Why you are adding bromine? Here, directly we can't able to bring a iodine on this place. So bromine come to this place and H plus. That's our anti-Marconi-Kos rule. So you will get 1 bromobutane here. We will get 1 bromobutane. Now we need to convert the bromine into what? Iodine. We have a very important name reaction. Finkelstein reaction. What is Finkelstein reaction? Use sodium iodide in dry acetone. Hope you remember, my dear. Yes or no? Sodium iodide. So what happened? This NaBr cut, the iodine come to this place. Yes, we'll get our product. Which one? N-iodobutane. So if you want to bring iodine at the first position, direct method is not there in an alkene. First to bring HBr, that is anti-Marconi-Kos rule. Then bromine we can replace by iodine. Clear? Ready. Question number 12, 2-chloropropane. Okay, let me write the structure of 2-chloropropane. 2-chloropropane to propanol. Okay, propanol. Propanol. How it is possible? How it is possible, my dear? Take the compound 2-chloropropane. So completely remove the chlorine first. So that is by what? Alcoholic KOH. That's our beta elimination. So halogen go from alpha, hydrogen go from beta, put a double bond between alpha beta. So propene is ready. Now how to get a OH on this position? Let us bring our HBr in presence of peroxide. That is our Andy-Markovnikos rule. Yes, Andy-Markovnikos rule we can apply. So we will get 1 bromopropane. Right, 1 bromopropane, and how last the bromine we can convert it into OH by aqueous KOH. Yes, all of you, aqueous KOH. So practice the question, then the reactions also will be easier. Okay, all. So 2-chloropropane, if you want to convert into propanol, first remove chlorine completely by beta elimination, then add, if you want to get one at the end, if you want to get a halogen at the end, we have to use Andy-Markovnikos rule, and bromine we can replace by OH by aqueous KOH. Question number 13, chloroethane. See all, chloroethane to butane. Chloroethane to what? Butane. It's very easy, you know. How many carbon in the reactant side? 2 carbon. How many carbon in the product side? 4 carbon. If you want to double, 2 become 4. Double mean Wurtz reaction. Yes, Wurtz reaction starting with the haloalkane itself. You know, this is 1 chloroethane. Let me take one more chloroethane and let us put 2 sodium in the middle, right? And if you treat it with what? Dry ether medium, what happened? The NaCl out and the remaining alkyl group get joined. You will get the compound butane. Simple reaction. Just one step. Question number 14. How to convert benzene to diphenyl? When you remember the diphenyl name, a immediate one, I think one name reaction comes to your mind. That is which one? Fittig reaction, right? Fittig reaction. But that is from chlorobenzene and all, haloarene. So first to convert benzene, let me add chlorine in presence of anhydrous AlCl3. Let me bring chlorine on benzene. Now it is chlorobenzene. You know, chlorobenzene, 2 chlorobenzenes when react with the sodium in presence of dry ether medium. What happened? Sodium take both of the chlorine. Actually 2 chlorobenzene required, right? 2 chlorobenzene, 2 sodium take both of the chlorine and the phenyl group get joined. One phenyl combined with another phenyl, what you call diphenyl or biphenyl. This is our Fittig reaction. So Fittig reaction actually starting from haloarene. So first to convert benzene to haloarene. That's chlorination, bromination, anything. Then we can use it. Question number 15. Chlorobenzene to. How will you convert chlorobenzene to 2-chloroacetophenone? What is that 2-chloroacetophenone? Chlorine. And what is acetophenone? COCH3. You know, this is number 1, 2. Therefore, 2-chloroacetophenone. Just one step. What is that? What is that? How to get a acyl group on benzene ring? Friedel-Crafts acylation. What is Friedel-Crafts acylation? Add CH3COCl in presence of anhydrous AlCl3, my dear. Okay. So chlorobenzene, chlorine is a ortho-para directing group. Halogens are weak ortho-para directing group. So when you do the electrophilic substitution, that will go to ortho and para. Yes, we need ortho. Yes, it can be formed. So this is our Friedel-Crafts acylation. Question number 16. Ethanol. Ready. Ethanol to but1-ine. But1-ine. In order to get a alkyne, we have a special reaction, my dear. So let me take the ethanol first. First the ethanol, let me treat it with the SOCl2, thionyl chloride. Thionyl chloride. So OH will becomes what? CH3CH2Cl. To a haloalkane, if you add, what you want an alkyne, right? A haloalkane, if you want to make it as an alkyne, at the end, we have a reagent Na plus C triple bond CH minus. What do you know what is CH triple bond? CH is called ethine. This hydrogen is acidic, so it is replaced by sodium. So sodium salt, sodium ethine. So that if you treated, what happened? This Na and the Cl cut as NaCl, then you will get CH3, CH2, C triple bond, CH. See, this is butane. So if you want to get a triple bond at the end on a haloalkane, if you treated, so the haloalkane treated with the NaC triple bond CH. Ready? Propene. Next question, propene. Okay, let me take propene. Propene to 1 nitropropane. Propene to 1 nitropropane. How to get this reaction? Let us start. So propene, take it all. Propene, propene. Let us make it a haloalkane first, because haloalkane in which nitro group, how you get, we studied. What is the reagent? AgNO2. Right. So let me treat first with the HBr in presence of peroxide. So what happened? Negative part comes to first position. Okay. So we will get a 1 bromopropane. See how many times this Markovnikov and all repeating here. Now how to convert the bromine into nitro group? We have the reagent AgNO2. You know, AgBr out. We get CH3, CH2, CH2, NO2. 1 nitropropane. So can we use KNO2? No, KNO2 will give you ONO. Okay, don't forget. And 1 chlorobutane. I think it's very clear from that name itself. But you have to make it oct. But 4 carbon, oct 8 carbon. So what is that? Wurtz reaction. So 1 chlorobutane. 1 chlorobutane. 1 chlorobutane is this one. You know, Wurtz reaction mean treating with the sodium in which medium? Dry ether medium. You know, there are two haloalkane is required, 2 sodium required, 2 sodium take both of the chlorine and this CH3, this part will get twice. So we'll get the compound CH3, CH2, CH2, CH2. This is 1 alkyl group, same one more repeat. CH2, 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 CH3. Ready? So that is our doubling carbon which indicate Wurtz reaction. Question number 19, but1ene, right? But1ene, how can we write it? But1ene, we can write like this. Ready? But1ene to but2ene, we have to change the position of the double bond. Ready, easy method. So let me take butene first. Let me take butene first. To butene, let me add which one? HBr. No peroxide. Okay. So that is Markovnikov's rule follow. Negative comes to carbon with a less, positive go to carbon with a more hydrogen, and you will get 2 bromobutane. Right? You will get 2 bromobutane. Now 2 bromobutane, you have to remove bromine and we have to get a double bond. Yes, what is the reaction? Alcoholic KOH, beta elimination. You know, halogen go from alpha, hydrogen go from beta, will get a double bond in between. According to Zaitsev rule and all, this is the major product. Maximum double bond should come at the middle part, more substituted part. Okay, so if you want to convert but1ene to but2ene, first get a bromine on the second position by Markovnikov's rule, then beta elimination. Question number 20, chlorobenzene to phenol, that is our direct method. Which one? Dow's process, right? Chlorobenzene to phenol. What is the reaction, my dear? Take chlorobenzene. Chlorobenzene first treated with what? Aqueous NaOH. Do you remember the temperature? 623 Kelvin and 300 atm pressure. We will get what happened? This HCl out, we get ONA. What is benzene with ONA? Is called sodium phenoxide. Sodium phenoxide when treated with HCl, this NaCl cut, we will get phenol. That's called what? Dow's process. Chlorobenzene to phenol is called Dow's process. Next question, let's discuss benzyl alcohol. What is benzyl? Benzene with the CH2. Benzyl alcohol to 2-phenyl ethanoic acid. Ethanoic acid means 2 carbon. Second position there is a phenyl ring. This is the compound called 1,2. So 2-phenyl ethanoic acid. How it can be possible, my dear? See, here on benzene ring only one carbon, but here on benzene ring 2 carbon. So we need to increase one carbon, bring cyanide. So but directly we can't bring cyanide on OH. So first of all, treated this with SOCl2. So the OH will convert it to what? Cl, right? OH will convert it to Cl. Now we can bring which one? Alcoholic KCN. You know, Cl and potassium go out, cyanide comes. Now you see one carbon extra, ready. Now we discussed in one reaction how to convert cyanide into acid. How many of you remember? How to convert cyanide into acid? H3O plus acid hydrolysis. Then you will get benzene with what? CH2COOH. So if you want to increase one carbon, again I am reminding you, alcoholic KCN, cyanide we have to bring it, ready. Next one, tert-butyl bromide. What is tert-butyl bromide? Tert-butyl bromide, right, this is the one. Tert-butyl bromide to which one? Isobutyl bromide. What is isobutyl? What is isobutyl? This is called isobutyl bromide. Dear all, this is called tert-butyl. This is called what? Isobutyl. Okay, don't forget to study the branches. The common names are isopropyl, isobutyl, sec-butyl, tert-butyl, neopentyl, neohexyl. Those terms please remember. So what is the step here? So let me take the compound. Which one? Tert-butyl bromide is there. We need to convert into isobutyl bromide. What is the method? Simple, all of you. First do, if you want to change the position means, do beta elimination first. Alcoholic KOH. So halogen will go from alpha, hydrogen go from any of the beta. Let me put a double bond here. So we will get CH3, CH3, double bond CH2. Ready. Now you need to get a bromine at the end, right? So we need to add HBr in presence of what? Peroxide, anti-Marconi-Coase rule. So negative part goes to carbon with more hydrogen, positive part goes to carbon with less hydrogen. You get the compound as the CH and here CH2Br. Check it all of you. This is the compound same. See, this is the compound. Yes, the same. So if you want to convert tert-butyl bromide to isobutyl bromide, first eliminate the bromine by beta elimination. Then you have to do anti-Marconi-Coase rule. Question number 23. Chlorobenzene 2 para-nitrophenol. Para-nitrophenol. Ready. So chlorobenzene. Dear, chlorine is a weak ortho-para directing group. So ortho-para directing group, if you do nitration, yes, it's possible. So we can bring nitration first. What is nitration? Concentrated HNO3 and concentrated H2SO4 and heat. What happened? This chlorine nitro group will comes to the para position. Ready? So this is nitration, simple. But how to convert chlorine into OH? That is our Dawes process. Dawes process. What is Dawes process? First step, we treated with the aqueous NaOH. Normally in chlorobenzene to convert phenol, we are using 623 Kelvin and 300 atm, right? But here, what is the temperature? For 43 Kelvin and high pressure that we are applying. Because nitro group is there, it makes the removal of chlorine and all easier one. So H and Cl that we will cut, we will get which compound? ONA and NO2. And how we get this ONA to OH? Treated with HCl, NaCl cut. Yes, we will get the compound OH and NO2. So how to convert chlorobenzene to para-nitrophenol? First on chlorobenzene, we have to do nitration. So you will get nitro on the para position. Now the chlorine we have to make into OH group, that is by Dawes process. And the next chlorobenzene to toluene. How to convert chlorobenzene to toluene? Can you tell me what method can be applied, my dear? How you convert a haloarene into alkyl benzene? It's very simple. That's through our Wurtz-Fittig reaction. Wurtz-Fittig reaction. One haloarene treated with a haloalkane, right? So let me take the halo. You want CH3 group, right? So that CH3 containing one haloalkane, I'm taking CH3Cl. And you know, there is 2 sodium is required in what medium? Dry ether medium. You know, when a haloarene react with the haloalkane, the halogen, both of the chlorine are taken by sodium and the benzene aryl and combined with the alkyl, you will get a alkyl on aryl ring, that's toluene. So haloarene when combined with the haloalkane in sodium and dry ether, the alkyl and aryl part will join, that's called Wurtz-Fittig reaction. Next question, aniline 2. Aniline 2. How to convert aniline to iodobenzene? Aniline to iodobenzene. Hope you remember. Yes. So what is our reaction? Aniline. Take aniline. Aniline first react. Diazotization. What is diazotization? NaNO2 and HCl at 0 to 5 degrees Celsius. The NH2 converted into N2Cl, diazonium salt. The diazonium salt, how you can convert it into iodine? Warm Ki, warm potassium iodide. You know potassium iodide contain Ki, the Cl and the K as removed as KCl. So KCl out, the nitrogen gas out, and the iodine come to benzene ring, will get iodobenzene. Same way they can ask you fluorobenzene also. What is that? Aniline on diazotization we get salt, on which we will use what? HBF4. Fluoroboric acid. Later on heating you will get a fluorobenzene. Don't forget that reaction also. 26th question, methanol. How you convert methanol to ethane? Methanol to ethane. See all here, 1 carbon left, 2 carbon right, and it is an alkane. Wurtz reaction. To double the carbon mean Wurtz reaction. So alcohol first treated with the SOCl2, it becomes haloalkane because Wurtz reaction is possible in haloalkane. Now this haloalkane when you treated with the sodium in presence of dry ether, you know this during Wurtz reaction actually we use 2 same haloalkane and 2 sodium. The 2 sodium take this 2 chlorine out and the 2 CH3 will join, you get CH3 single bond CH3. So from a haloalkane, if you want to double the carbon mean, it will be Wurtz reaction. Next one, convert the compound ethane. Okay, this is ethane to 1,2-dibromoethane. You know vicinal dihalide. What is vicinal? If the 2 halogens are on adjacent carbon is called vicinal dihalide. What is the method? See, first this ethane to which let me bring a chlorine. So you may think, sir, we need bromine, right? Just to wait all of you. Chlorine or bromine, we can use it in presence of light. What is that? Substitution. What is substitution reaction? Remove 1 hydrogen, add 1 Cl. So we get CH3, CH2, Cl, chloroethane. Right? Chloroethane. Now let me do beta elimination, alcoholic KOH. So halogen go from alpha, hydrogen go from beta, get a double bond between alpha beta. Ready, ethene is ready. Why I made into a alkene? The given is an alkane, I made into alkene to get 2 bromine on adjacent carbon. See this one how to convert CH2Br and CH2Br dear, add Br2 in CCl4. When you add Br2, 1 bromine go to this carbon, 1 bromine go to this carbon, that CCl4 is the medium. So okay, so if you want to convert a alkane into vicinal dihalide, first the alkane convert into alkene, then you do bromination, add Br2. Next one, tert-butyl chloride. What is tert-butyl? This is called the tert-butyl chloride 2233 tetramethyl. Okay, tetramethyl butane. What is this method? Can you able to understand? Any idea? This is our Wurtz reaction, my dear, because you see this part is twice. Yes, this alkyl part is double. That is Wurtz reaction. So for Wurtz reaction, what you have to do it? Take 2 same haloalkane. Take 2 same. This is tert-butyl chloride. Let me take 1 more tert-butyl chloride. So take 2 tert-butyl chloride, and mix with what? Mix with what? Sodium. Sodium. And what is the medium? Dry ether. What happened? Sodium take both of the chlorine, this alkyl group and this alkyl group join, you will get this compound. Clear? Ready. Question number 29. Chloroethane. So 28 over, right? 29. Chloroethane. Okay, what is chloroethane? CH3CH2Cl. 2. Tert-butyl. You know what is tert-butyl? Just we discussed now. This is tert-butyl. Ethyl. What is ethyl? CH2CH3. Ethyl ether. How to convert chloroethane to tert-butyl ethyl ether? We studied haloalkane, how to convert into ether. That is our Williamson ether synthesis. Haloalkane, when react with the sodium alkoxide, we get ether, right? So this is haloalkane. Ready? So haloalkane, let me take it. Okay, it's already there. So this CH3CH2 is, yes, it's already here. So remaining part is from where? That is from your sodium. So NaOCCH3CH3CH3. What happens? Simple reaction. This NaCl cut out and this plus this. Yes, you will get this compound. So what is the name of this compound? This is chloroethane haloalkane. What is Na on what is this compound? Tert-butyl and with the oxygen called tert-butoxide. So this is called sodium tert-butoxide. Okay. So when haloalkane react with the sodium tert-butoxide, this NaCl cut and you will get the ether. This is called Williamson ether synthesis. Let's go for the last question. Question number 30. How you convert bromoethane to ethane? Come on, my dear. Which reaction? Which reaction? We didn't study yet in this area. Bromoethane, how you can convert into ethane? Do you remember Grignard reagent? Yes. So let me take bromoethane. What is Grignard reagent? How you make Grignard reagent? Treated with Mg in presence of dry ether. You know where this Mg plays? The Mg plays in between the carbon and Br. You will get CH3, CH2, MgBr. Ethyl magnesium bromide. Ethyl magnesium bromide. This is our Grignard reagent. Dear, in Grignard reagent, magnesium carry positive charge and the alkyl group carry negative charge. You know, when Grignard reagent undergo hydrolysis, you know, hydrolysis mean H2O contain which all ion? H plus and OH, right? See, H plus go to this side and OH go to this side. What do you get? CH3CH3. Yes, that is our product ethane. Okay, all. So if you want to convert a haloalkane into alkane, we can do which one? Many methods are there actually. Many methods are there. Either otherwise, we can do what? Beta elimination. If you do beta elimination, that becomes ethene. Ethene to which if you add hydrogenation, that become ethane. Any method can be suggested. Here I want to just go through the Grignard reagent also, therefore I just used. So bromoethane with the Mg, you get a Grignard reagent. Grignard reagent on hydrolysis, you will get alkane. So dear, so we completed around 30 conversion question. Most of the haloalkane reactions, I think it's covered through this reaction. So keep practicing. We will be there. We will be here to discuss some more other organic chapter with the 30 questions each. So keep practicing the same all 30 questions and be confident in our organic conversion questions.